Okay, we're continuing in section 1.1, and right now we'll be looking at functions. And the first thing we'll take a look at is function notation. Function notation starts with the key letter, which is the name of the function. Here we say this is f of x, and then we have our independent variable. And then we have what's called the rule or the body of the function. A function is a set of instructions that you are to carry out on the independent variable. The result of the function, the result of the function is what we get when you evaluate the function. This first piece of the function in mathematics is said to be f of x. So if there's a g up front, at the name of the function, we would say g of x, and so forth and so on. Now, evaluation of functions. So let's say I have a function, a very simple one, f of x is equals to 2x plus 3. And let's say I have a second function, g of x, right here is negative x squared plus 3x minus 2. Here we see the first advantage of functions is that you can have several functions at one time. Just change the name, different letter, f, g, h, I, k, l, many functions. Right here, this right here is said to be f of 2, and this means evaluate the function at 2. In the vernacular, it means plug in 2 for x. So f of x, so I'm using this function right here, and so I'll go 2. I like to put brackets around the number I'm plugging in. That prevents sign errors. And then you do the algebra to simplify. 2 times 2 is 4. 4 plus 3 is 7. And so we say f of 2 is 7. We can also write this as an ordered pair. When I plug in 2, my result is 7. Again, we can see this means right here, f of 2 means evaluate. The function f when x is equal to 2. That means you got some harder work to do. Now obviously that's just way too easy. But one of the major advantages of functions is that you can plug more into a function than a simple number. For instance, I could have f of m, which would simply mean plug m into the function, which is just 2m plus 3. Into the function, I can have, for instance, g of m. I guess I just use m. Let's go to g of p, and that will simply be negative p squared plus 3 times p minus 2. One of the more interesting things that I can plug into a function, and again this is right here is a key example, is I can plug in negative x. So g of a negative x would be negative x squared plus 3 times negative x minus 2. And so of course, PEMDAS holds here your order of operations. You have to do the exponent first. And so what we will end up with is negative. What we would end up with is negative x squared plus 3 times negative x minus 2. Then I can do my multiplications. What happened there? Then I can do my multiplications, which would be negative times x squared is negative x squared. 3 times negative x is a negative 3x, and then the negative 2 comes down here. Notice I just get another function when I plugged in the negative g of x. Another key thing to notice is that the x squared term remained the same as the original g function, negative x squared, while the 3x term, when I plugged in the negative x, the 3x term became a negative 3x. The second key example, right here for my g of x, is if I make the function negative. So if I go negative g of x, when I go negative g of x right here, what I'll get is just multiplying the entire function itself by a negative sign. And that simply causes all the signs to flip. That leaves me with x squared minus 3x plus 2. That's the negative g of x. The last and the most interesting thing for a function is when I have to plug in something more complex, say a binomial. So binomial. Say I have g of x is equal to negative 2x squared minus 4x plus 3, and I want to find the g of h plus 2. Well, what's a person to do in this situation? I don't know. Oh, well, I guess just go home and give up. No. This simply means evaluate the function when x is equals to h plus 2. And so that means I am going to plug in h plus 2 for x. And so this will be equals to negative 2 times h plus 2 squared minus 4 times h plus 2 plus 3. What I have done is I have substituted. Everywhere I saw x, I wrote h plus 2. Everywhere I see x, I solved h plus 2. Now, PEMDAS, my order of operations, say I must do my exponents before I multiply. And so the key question is, so this right here will be a side note, is what is the answer to h plus 2 squared? Well, there are several ways of working this out. The most common way that this is taught is by using what's called the FOIL method. And in the FOIL method, you take your h plus 2 squared and you write it as h plus 2 multiplied by h plus 2. The FOIL, the F stands for first. You multiply the two first terms together. H times h is h squared. And then the O stands for the outer terms. You multiply the h times the 2, which is a plus 2h. Then the I stands for the inner terms. You multiply the two inner terms together, and that's plus 2h. And then the L stands for the last terms. You multiply the last terms together, and that gives me a plus 4. And that leaves me with h squared plus these two middle terms are like terms, so you can simplify them and add them together, plus 4. And there you go. You have foiled this lovely thing together. Now, if you're like me and have been taught how to foil like 500 times and can never remember it, there are other ways of getting to the answer of h plus 2 squared. For example, you can use the back of the old notebook trick. H plus 2 squared is equals to h plus 2 times h plus 2. Well, you remember the multiplication tables on the back of your book where you would have a times right here and then 1, 2, 3 and then 1, 2, 3, and then they had the whole thing filled out. Remember that right here? Well, you can do something similar right here to get yourself to your answer. erase, 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 erase. And what you would do is you put the first h plus 2 up here, and the second h plus 2 down here, and then you just multiply. H times h is h squared. H times 2 is a positive 2h. 2 times h is a positive 2h. And then 2 times 2 is a positive 4. And look, you get the same 1, 2, 3, 4 terms down here that you got up here. And so then you just add like terms. And that takes you to your answer. Isn't that more fun? Another way you can multiply them. So again, h plus 2 squared. So here, what you want to do is you want to line it up just like you're doing old school multiplication. Again, this is h plus 2 times h plus 2. And so you want to go h plus 2 times h plus 2. You'll do your old school multiplication. And so here, right here, you'll go, need the highlighter. What you do is you go, first you go h times 2 right here, which is going to be 2h. And then you would go h times h, which would be h squared, plus, and then you would go 2 times 2, which is 4, and then you would go 2 times h, which is 2h. And then you just add them together. That leaves us with h squared plus 4h plus 4. Now all of that work right here was to answer this simple question. What is h plus 2 squared? Now we know what h plus 2 squared, we can get back to work in working this problem out. So g of h plus 2 is equal to negative h plus 2 squared minus 4 minus 4 times h plus 2 plus 3. But I now know that h plus 2 squared is h squared plus 4h plus 4. And I just carry everything else down. And now I can multiply. I distribute the minus sign, negative h squared minus 4h minus 4. Then I distribute the negative 4, negative 4h minus 8 plus 3. And then I group like terms. My h squared has no like terms. However, the 4h, there, 4h here and a 4h here, those are like terms. So those combine to give me a negative 8h. And then I have my numbers 4, 8, and 3. And those combine to give me 4 minus 8 is negative 12. Negative 12 plus 3 is negative 9. I hope. Yeah. And that, my friends, is g of h plus 2. Notice I get another squared term, but there are no more x's, there are only h's.